And any longer questions, please keep them in the end. Otherwise, if it's a short one, just put it in the chat or unmute, whatever you prefer. If you have any questions to any mocks or quizzes or anything, make sure to have a screenshot or something on hand so we can discuss it directly in the Q&A. Okay, so then let's start with the exam structure, because that's what we're working for. So we will be having a 30% final grade exam. It will be on LMS, as we know. It's going to be about 45 minutes for 32 questions. So it's going to be a race against the time more than it is going to be really a question of knowledge. So they're trying to see if you understood the things, not if you can look it up. But obviously documentation is allowed, as it is with Proctorio. Moving on to the course material, we'll start by looking at the operational objectives. So there's two main objectives. It's customer satisfaction and operational performance. One of them looking at, are our customers happy with what we do? Mainly looking at what they consider quality and how much they are willing to pay, versus looking at our own efficiency of the operation, the productivity, our KPIs, so anything that goes into making money. For these objectives, we have a structure to match. This one will take us through most of some. It is the SIPOC structure, or as we better know them as supplier, input, process, output, and customer. Those are the 5 aspects that you need to keep in mind. Now, on the next slide, you will see a table which looks like this. This is mostly for your CRTLF during the exam, but I want to quickly point out the highlighted resources and material, because the difference there is important. Specifically, resources are any type of inputs which you will use multiple times throughout their lifetime. So like staff, machines, data, all those kinds, they go into resources. Materials are the things that get used during the process. All right, let's move on. Now, operations and process need to keep improving because of change. Now, change can come from various origins, and they're all forms of stakeholder pressure. Those stakeholders can be multiple people. They can be either clients, business clients, or individuals. They can be shareholders, employees. They can come from other entities like publics or legal entities. So they can come from basically any different point of interaction you have in your business. Now, depending on where you are in your industry and in your environment, the pace of change will be different. So there's 3 different steps that we look at. It's a limited, moderate, or continuous pace of change. Limited is you do not have to invest much in improvement, because you are secure to have a customer base. But this is mainly just for governmental institutions. Then we have moderate change, which most businesses that we know fall into. Anything from airplane operators to restaurants and anything will be part of moderate. And then continuous pace of change, that is anything that is very, very much trendy. So fashion can be one of them. A lot of IT, forefront of research projects, those things, they go into continuous change. Now, because we have that change, we need to have different ways to approach improvements so we can keep up with those paces of change. Now, this links back to a Eastern philosophy called the Kaizen philosophy, which is the idea that you keep improving as we go along. Next, we will look at the Lean Six Sigma approach, which is, I'll say, the guidance tool through all of SUM. It's based on Lean, which is the strategy to eliminate waste. So any resources that are not used to their maximum, and Six Sigma eliminates the variations through using the DMIC 5-step process. I will keep calling it DMIC. I do not know how you guys want to call it, but it's just, for me, that's easy. And what I consider under this is the define, measure, analyze, improve, and control steps. As you see, these steps, I've put a color to them, and we will move on to see the colors as the frames of the slides, so you'll always know where we're at. Now, I have a first question for you guys. Now, going back to the pressure on operations that we've looked at, we have here four possible inputs. The recording is being taken on a different laptop. It's not using the service it's not using the Teams recording, therefore you cannot see the bar. That is how it goes, Carmen. And thank you. So please use the chat to answer this question if you haven't already. I'll give you about 30 seconds and then we move on. All right, as most of you guys guessed correctly, it would be C, mainly because the other ones are putting pressure onto operations, while C reduces the pressure of operations. Now, a little follow-up on that is, what do you think, where do those pressures come from? So like A, what kind of a source of pressure is the pressure A? That is correct, Matthias and Rohit. That is exactly, it's a time pressure stemming from the clients. Next, the salmon supplier, what kind of a pressure would that be? Yes, Carmen, that would be a supplier, exactly. That would be from the supplier, but also specifically, this would be from public organizations that concern specifically corporate social responsibility. They will put pressure on you to stop interacting with that supplier. Then the expected return on investment decline, which means our shareholders, they expect less of us now. This gives us, I'll say, more possibility to explore different options, and this is a less of a pressure, so a decline in pressure, so it doesn't put more pressure, obviously. Now, what about the new restaurant that opened? Yes, that's it, guys. It's competition. Exactly. If we have more competition, we're going to have to basically fight against them for our clients, so that puts pressure on our operations. Now, this is the question we just answered. And then let's look at that. Which of these is not a resource for a hotel? This goes back to the CPOC structure. All right, so the big batch of you guys got it correct. It is fruit for VIP amenity baskets, D. Can you tell me why? Well, it is because there's the difference between a resource and a material is that it is used in process of the, exactly, it's used as the process, as the process goes along, the fruit basket, it will not return, the fruits, they will not return, they will be eaten up, so they will be used up. Therefore, it is considered a material, exactly right, like Rachel said, and not a resource. The other three fall under input. Yes, exactly. All of those fall under inputs, just some of them are materials and some of them are resources. Then let's move on to our DMIC structure. So starting off with the define, we will look at what needs to be defined. So the main thing that needs to be defined is the problem. And with the problem along goes, why is it a problem? So the customer needs and the expectations. We need to look at how big is the problem and what can we, in which directions can we tackle that problem. Then we look at the objectives. So we look at where we're at and where we want to go. We decide on a way to do it through methodology, and then decide who are we going to put in charge of that by putting it onto the project team. Now, to define stuff, we can use multiple tools. One of them is the voice of customer, the VOC. Now, this will explain us basically why there is a problem. It will show us our customer profiles, their needs, their wants, and their willingness to pay through their purchases that they made. So this is data that we already possess, we just need to use it. We will also be able to measure their satisfaction level, their idea of how important the specific tasks are or what they consider problematic through surveys, through reviews, and through social media. All of these things we collect as data and use as the voice of customer. From the voice of customer, we will also get the drivers and the CTQs, so the critical to quality, which we will use then further in the measurement phase. But first, let's look at the different tools that we still have for defining our problem. One of the ways to look at defining is to create a chart, specifically in this case, a flow chart. Now, the flow chart starts with a green circle, goes through different processes in blue squares, decisions in orange rectangles, and ends on a red circle. This is a structure that Professor Koppel likes to have. And there was also a question about the structure on the mock midterm, so I decided to put it in the correct way. And then we have the swim lane chart, which is basically the same thing as a flow chart, but now the different steps of a process, they are put into different categories. In those categories, there's two ways for those categories to be defined. It's either location-based, so where do those things happen, or it's resource-based, so who or what is required to do that. For our little how to get through BOSC 3, I've decided to use a resource-based style for swim lanes. Now, here we go back to CPOC. CPOC is also a tool that we use to define our projects. And again, we can use the central part of our flow chart or of any chart that we've had so far as the guideline for the process. So let's consider one of those specific processes. Let's say attend class. Let's see, what kind of, let's say, input do we require to be able to attend class? What do you think? Exactly, a computer or a laptop, that is already a good start, yes. We will need that to go online specifically. Internet, exactly. So just different types of inputs, maybe also the presentation, the prof, exactly. So the prof can, in this case, the prof can be either an input, so a resource, a staff, or it can be a supplier, for example, for the PowerPoint presentation or for the videos that we use for class. Exactly. And then one of the things you need to be careful about when you look at suppliers is that sometimes a customer can also supply something. It can be, for example, a reservation in a hotel, or it can be a food order in a restaurant. So just because the last step of those says customer, it doesn't necessarily need to mean that all customers are the people that pay. Customers can also be, for example, specific departments in your operation. Now, let's talk about the project charter, which is a global summary, basically, of everything that we've defined during this first phase of DMIC. So you will just take all of the problems that you found, all of the methodology that you want to use, you take the people that you have, and you all just merge it into one big summary. That will be your project charter. Now let's have another question. So do you remember the swim lane chart? Now there's two different traits that a swim lane chart can be based on. Which two would those be? That is exactly correct. Yes. Nice job, guys. Exactly. It can be a location or a resource. Then we've already started on this with the inputs and the suppliers. Now let's focus on the outputs and customers. So you're attending class. What kind of an output do you expect to get from it? Very nice. Yes, exactly. Those are some good, yeah, exactly. Those are some good outputs. Specifically for outputs, we also like to specifically have things that are, let's say, goods. It's not, most of these are like service type outputs, but we also like to have goods as outputs. So what would be an output as a physical thing that you have from class? Yeah, a grade maybe, but also specifically, yeah, diploma. Very good. Or just exactly, Carmen, or just your notes that you have from class, exactly. And who's the customer for the classes? That's right. Nice job, everyone. That would be us, the students. Here you have a little summary of what we've discussed. This is non-exhaustive, so there's a lot of things that you can still add to each part. This is just a bit of an idea. Now let's move on to the measurement phase of DMIC. Now the objectives of this phase is specifically to measure how well we are doing our job, so our performance, our quality, to measure how stable we can do our processes, and specifically also to define like where we are at a bit, so from where we're at to where we are going, so the gaps. For that we can use different tools, one of them being critical to quality. Now critical to quality is a measurable objective which is considered as very, very important by the customer. So it can range from anything, really. It can be like wanting to be able to sit down in a bar, to wanting to get a coffee within 3 minutes, just things that can be measured. And these, they are usually taken from drivers. And drivers, they are the dimensions of a service and product. So like the different aspects that we look at. And these, again, they are taken from the voice of customer, which we've looked at during the define phase. Next, another measurement tool that we have would be just various charts and visualizations of our processes. Now, one of the ways to do it is with the X chart or the P chart, which is a process stability measure. So in that way, we can see like how much variation compared to the mean that we have. While for a movement measurement, we have a spaghetti diagram, which traces all of the movements of staff, for example, and allows us to minimize their walking time and therefore make us more effective. The probably most important measurement tool that we've looked at so far is the capacity and the cycle time. Now, for capacity and cycle time, we usually in Cobbles classes see it as the box below shows you. So you will get a task name, you will get resources, you will get the time it takes to finish one unit, and you will get or have to calculate the capacity. Let's start with a cycle time. Now, the cycle time of a process will tell you how long it takes for a unit to go from the very start of the process to the very finish. So to go through every step of the task. Then the capacity itself, let's do cycle time first. Let's finish cycle time first because I have animations. And this is usually calculated as the sum of all the times that it takes to finish a unit. So you will add up all of those numbers. Now let's move on to capacity. So capacity is basically how many units can you produce per hour, per minute, per time unit. And that is calculated by dividing the time that it takes per unit with the resources to get your capacity. The most important thing about this is that your total capacity is always limited by the lowest capacity of the process. So, for example, if we bake cake and we have one oven and we need to basically put every cake singularly through that oven and it takes us way more time than every other step, this will still be our cap for the capacity. And we call this the bottleneck. Now, let's talk about ways to improve capacity. Now, one way to improve your capacity is by reducing the task duration of the bottleneck or improving the efficiency at the bottleneck. Another way to improve capacity is to increase the number of resources at the bottleneck, which means that if you, for example, have one oven in the beginning and you add a different oven, you can now do double the amount, which will speed up the whole process. Additionally, you can also merge two tasks, so have the bottleneck be merged together with a different task, which will overall increase the capacity. Then, let's move on to a question for measurements. Which of those are possible CTQs for a class or lecture? There's multiple possible answers, by the way. Remember that CTQs, so critical to quality, have to be measurable and objective. So B, that's very good, yes. A is correct as well. Now, I guess A and B are fairly clear because they have a very easy way to decide that they are measurable by the time limit. But then we also have C is a yes or no question. So do we have a break or do we not have a break? And if we consider it to be let's say a yes or no question, we can clearly measure. We can say that many times we had a break, that many times we didn't have a break, and that's how it affected our class lecture. Now, the one that is questionable whether it is a CTQ or not is D, because some time, just keeping some time is very unspecific and it's really hard to measure. Like, how much time did we actually spend? We don't know. How much time is important? We don't know. So the only one that is very unclear is D. Good job, everyone. Let's move on. Professor Koppel, when looking over the PowerPoint, decided that there wasn't enough math questions, so I've added a few. So here you go. You have, what is the cycle time for baking a cake? We have some winners here. Good job, guys. It is 2 hours, 5 minutes or 125 minutes. How did you do it? By adding up all of the different, all of the different times that you had. Exactly. Now, of course, the next step will be, what is the maximum capacity? Like, how many cakes can we maximally do within an hour? I'll give you a bit more time. All right, so let's check in. Now, if you look at all the capacities, you will see that actually the lowest capacity is for the decorations. So if you have 2 people decorating a cake each half an hour, you will have 4 cakes an hour as your lowest capacity, which also is your bottleneck and therefore your maximum capacity. Good job, Carmen. Also the others, I guess you looked at the 1 hour for 6 oven. That is also a very low one, but not quite as low as the decorations. Now, next up, let's say we want to improve our cycle time. So we had 125 minutes. How do we improve that cycle time? Remember that decorations is our bottleneck. And now I'm really sorry to tell you, but you guys, you all fell right into my trap because I'm so sorry. Adding additional resources cannot improve your cycle time. Your cycle time will not be improved through additional resources. For example, if you bake a cake and you now have 2 ovens baking next to each other, that doesn't make the cake bake faster. It makes you be able to bake more cakes per hour, but the cake itself will still take the exact same amount of time to be baked. So we have E, none of the above. Your cycle time cannot be improved through additional resources. Is that clear? Because this is a very important concept and will be definitely tested. All right. Nice. Moving on. Now, thank you, Matthias. Let's move on to time series forecasting. Now, time series forecasting is our, let's call it a recap of statistics of last semester mostly. We have a defined notation. We usually use X as our historical data, F as our forecasted values, and as our number of forecasted values, and we estimate, blah, blah, blah. This is mainly for CRTLF stuff. But now let's go see at the different forecasting methods that we have. Now we have looked at 3 main smoothing methods for short term, and then the decomposition method, which is usually used for long term. Now the thing about those 4 methods is that unless you actually analyze all of them according to errors, we can never be quite sure which one is the best one. Let's have a look at them specifically. So time series forecasting can be done with a simple moving average, which is written as SMA equals to N, with N being the amount of observations that you take into consideration for forecasting. So for example, if you have SMA equals to 3, you take the last 3 days that you've had observations from, and you average those out. Now, as you consider, obviously, the smaller that n is, the less back you go in your observations. So if you have an n equals 2, this means you only take into consideration the last 2 observations, so yesterday and the day before, which means that it's very, very reactive. So if you have any shocks onto your observations, you will easier be able to forecast something with a smaller n. But on the other hand, if you used to have a shock just before and you're past the shock, you probably will want to have a larger n so that you're back to a normal track. Now for forecasted, the formula that we use is very, very simple. It's just going to be an average formula of the previous n observations, and then we'll drag it down and it will automatically move down as you go. Now, one thing to look out for is that you need to make sure that you don't do the forecasting for the first n cells, because they don't have the correct amount of data before, as you can see in the little image that we have. Next, we go on with the weighted moving average. So we now decide that we care more about specific observations that are closer or further away from our date. Now we write them as W equals and then a percentage or an O point something. And one of the most important things that you need to consider is that usually W3 is the earliest day, so the day farthest away, which means the day that is highest on your Excel chart. This can be quite confusing. So you need to make sure that if you have a W1 equals 0.5, W2 equals 0.3, W3 equals 0.2, you make sure to turn them around, flip them as you put your calculation for the actual forecast. Now for this one, we do not have a nice average, so we have to manually type it, basically. So no nice function. Now, as a last easy forecasting method, we have simple exponential smoothing, which is written as SAS with alpha equals to the percentage. Now, alpha is the smoothing constant. And the idea of it is that alpha is the weight of the latest observation. So we use alpha to decide how much importance are we going to put on our last observation, how much importance are we going to put on our forecast. And yeah, the bigger A, or the bigger alpha, the more influential also our newest observation will be, so the more weight it will have. And then our more difficult or more intense forecasting will be the decomposition method, which is, the idea of it is to basically pick apart our data set and sort it into 4 different structure parts of a time series, which usually is the trend line. So the overall increase and decrease. If we only do that, we also call it linear regression. This is basically just like, where are we going overall? Then we have a seasonality, which is a repeating pattern over certain amounts of time. This can be a week, a month, a year. But if it goes over a year, if the seasonality is over multiple years, we now call it a cycle. And sometimes, for example, during COVID, data can be just very unusual, and that would be a random variation. So anything that doesn't really have a repetition. So for the decomposition method, we only look at the trend line and the seasonality. Cycles are only seen in large quantities of data, and random variations are just spikes that you will recognize. Now, simple linear regression, how do we do the trend line? It's basically just, how do I make a chart in Excel with the data that we have, and how do I see the trend line? And this is basically just a little step-by-step on how to do it. in case you get nervous or something. But it's literally just put the data into a chart and get a trend line. And then, wait, actually, let me quickly add something to that. Obviously, you need to get the trend line equation and then use the trend line equation to calculate for each day the expected or the forecasted value. And if we have, the first day will always be day 1. So you will always use 1 with the first day that you have. And then you will move on to, for example, 2 weeks later, you will use 14 in your equation. Okay, now let's move on to seasonality forecasting. Now, the importance of seasonality forecasting is to get the ups and downs of your data. I was just asked if I know if we will be given an Excel file during the exam with some of the problems. The answer is no, very unlikely. We will not be given an Excel file, which is why we are not going to look further into exercises of the decomposition method as well. We're unlikely to actually have to do the full method ourselves. We're more likely to have problems that are short and focused on specific parts of it. Yes. Did that answer the question? I guess it did. Yeah. Okay, let's move on. Thank you. Calculating the seasonality index. Now, basically, we just, once you've made your trend line and you've made your forecast based on simple regression, what you now want to do is you want to, in percentage, define how far away from that trend is your actual observation. And to do that, you can use the formula that is presented in step 1. Which is just a very basic percentage difference formula. And then to do that, and then once you have your percentage, I'll say percentage moving away from the trend, you will then average those for each element within the repetition, which means that if you have a week, like if your time period is, let's say, over 3 weeks, what you want to do is you want to average all of the Mondays into your average SI, all of your Tuesdays, average them into your Tuesday SI, so you get an average curve. And then you use this curve, so these 7 averaged indexes, to then multiply them with the trend, which will give you the model forecast. Okay. Then, for all those forecasting methods, we need to figure out which one is the best sometimes, or which one makes sense to use in certain cases. Now, the best way to do this is with the mean square error, which is you always look at the value that you forecasted for a certain day, the observation that you had made on that day, you minus them from each other, and then square them. That will give you a, let's say, an absolute error. And it doesn't really matter if you start with the forecast minus measured or measured minus forecast, because obviously when it's squared, it won't matter, the minus will drop anyway. And then you drag that formula down through all of your measurements. You will sum that drag down list and then divide it. Yes, the linear regression and the trend line are the same thing. You will divide by the number of forecasts that you've made. So for example, if you have let's say a simple moving average of 3, make sure you take the forecast divided by the forecast amount, by the amount of forecasts that you have, not by the amount of observations, because your observations will be slightly more. Yeah. Okay, then once you've done that, you will have a way to look at your different forecasts and decide on the best model. Now, if you want to also calculate your margin of error, also written as EM or average margin of error, the only thing you still have to do is to get the square root of the mean square error, and that will be your error margin. Okay. Now, I would suggest to have maybe, maybe not. We're actually not that well in time, so we're just going to move on. Sorry, guys, we're going to power through this. It's going to be more math. It's going to be now a distribution. So we're going to start with random variables. And so a discrete random variable is a whole number only. And it's generally used with probability mass functions, so the probabilities of certain outcomes, while continuous variables, they are any value within certain limits, and they are usually used with probability density functions relying on the mean, the variance, and the standard deviation. Now, we have cumulative functions or mass functions, and the difference is that cumulative functions, they will be the sum of all probabilities lower than or higher than a specific value, and we'll look at that more closely later on. Let's start with the Poisson distribution, so one that we have new this semester, and specifically when to use it is we only use it with discrete variables. So we use it to predict the number of events that happen within a predefined time frame. So it tells me like how likely is it that a certain amount or more or a certain amount or less or a specific certain amount of events do happen. And the formula that we use is given to you underneath. You have the x, so the value that you want to look at, you have the mean, so the average of it, and you can pick between the exact value and the cumulative value. One thing that you need to look out for with the Poisson distribution is being careful with time units. Now, sometimes an exercise will tell you have, let's say you bake 2 cakes. Oh no, that's not a good example. Or, for example, 2 customers. You have an average of 2 customers appearing within 1 hour. Or you will have, let's say, 3 customers appearing within 30 minutes. And the important thing is that you always average them out on either per minute or per hour, not per 30 minutes or per 2 hours or anything like that. It needs to be per minute or per hour specifically. Was that clear enough? Fantastic. And let's move on with the exponential distribution, which is one that we use specifically for continuous variables. And it's we use it to predict how much time will be between 2 events, and these events, they can usually be predicted through Poisson. So through a Poisson distribution, you can get the amount of events within a time. And through the exponential distribution, you can get the time between the events. And the formula we use is EXPONENTIAL, and it is, again, being careful with the time units. Now, last but not least, we also have our normal distribution, or our Gaussian bell curve. And it basically works with most continuous variables, as we've seen in the last semester in statistics. And it tells us what the probability of a certain value, or more than a certain value, or less than a certain value happening is. And we use norm dist for that, as we've used before, with the x, the mean, and the standard deviation. We can also switch it around, and instead of looking for the probability of a value, looking for a value related to a probability, which means we invert everything, so norm-inv formula. Then here we have a little revision of how it works with the formulas. So usually if you have a curve and you look for anything above a certain value, let's say the yellow part is above x1, then what you're looking for is you calculate everything for the maximum, so 1, and then you minus the norm dist function for x1. Then if we have an exercise that will ask us to have a certain value or less, what we will do is we will get the norm, just the standard norm disk function, because the norm disk function always tells us how likely is the probability of everything to happen until that position, a cumulative norm disk function. And the last thing that we can do is we can minus two different probabilities from each other. So if we want to get the green area between x1 and x2, what we do is we calculate the probability, the cumulative probability until x1, and then we minus the probability of x2 to get the in-between part. All right. Now let's move on to our third stage of the DMIC strategy. That would be analyzing. All of this before, this was mainly measuring and partially analyzing, but now we're full on into the analyzing part of the DMIC. So here what we do is we now have measured our gaps. Now we need to analyze why they are there. We can go and find the root causes of those gaps. And we can also find different potential improving areas. So we can look at what kind of staff might be responsible, what kind of machines might be not functioning, where are those wastes coming from. So the tools that we have for that is one of them is the 5 whys, which is called a root cause analysis. And it's basically just, if you find that something is going wrong, you ask the question why multiple times. For example, let's say I woke up, let's say I'm too late for my Spanish because it's at 8 o'clock in the morning. And then I would ask myself, good, why am I too late for Spanish? That's because I woke up too late. Why did I wake up too late? Well, because I went out too long. That's how it goes. And then you just ask yourself that question, why, 5 times, and then that should get you to the origin of the issue. Then we have the value stream mapping diagram, which is also a part of the analyzing tools. It's basically, if you remember the flow chart from the define part, it's basically that. But now we split it into value adding versus non-value adding. For example, when I study math, doing exercises would be value adding. But going onto Instagram and just getting distracted would be non-value adding, obviously. Now, as part of value stream analyzing, we can use math to decide on a process cycle efficiency in percentage, which is we look at how much of the time that our process actually takes are actions that will bring us closer to our goal. So we use the total value added time and we divide it by the cycle time. This will give us the percentage of, let's say, productivity within our cycle. And we can also calculate how much money we lose, we lose through the non-value adding activities. So, for example, if a waiter has to move 5 times the way instead of 1 time, we still, even though it doesn't help our productivity, we still pay that waiter a wage, and we can base our calculations on that wage. Yes, so let's have a question. Now, what are the examples that could be considered non-value adding in this stream? Now, obviously, those are 5 processes, and what are different types of, I'll say, distraction or unusual time, unnecessary time periods within that. Yes, that's a good one, Carmen. Yes. Dreaming, exactly. That's a good one as well. Guess you can do that at any step of the way. Or, for example, let's say to everyone who arrived, let's say at actually 4:30 for the tutoring, let's say the 5 minutes that you waited, turning on the computer is a good one, the 5 minutes that you waited before our tutoring actually started, that will be, let's call it non-value adding time, because you're not actually using this time in a way that is productive. But now let's move on to the I from DMIC, the improvement section. And our objectives here are to identify how and where and like the possibilities of our improvements and like what their impact will be on our actual operations. The idea is to basically just have a huge selection of things that we can do, narrow it down to the relevant possibilities, and then implementing those possibilities. And we can do that through this three-step process. We decide on an approach. It can either be a top-down or a bottom-up approach. This is basically just where in the company, from where does it come from? Does it come from management, basically pushing down and telling the people what to do, or is it an initiative of an employee that gets supported by the higher-ups? Then we have a selection of the solution. So we will start with testing the solutions. We will have a financial assessment, so see how much money would go into each solution, and then a decision-making process. If anyone actually came to my HBP in BOSC 1, we had a decision-making process called Diadem. Nice little throwback for you there. Then we had an implementation plan and a budget to make sure that our solutions are actually on track with what we are required to do within our process. And then last but not least, that is brilliant, Ryan. Then we have for control, we have basically not looked at this step much yet. We've just scoured over it, so we need to make sure that we understand it's part of the whole DMIC thing. And for our objectives as control is basically after we've implemented all of our solutions, we need to measure again and to see if there was if our improvements have actually made our process better, more valuable, more efficient, less time consuming, higher employee satisfaction. And then we need to make sure we add our solutions to a standard operating process or protocol. And the tools that we can use for that is basically just writing everything down. So a standardization or a stabilization procedure. So we write guides, we write SMSs to our colleagues telling them of what they need to do now. And the other tool that we have, which is a favorite in the questions that he asks as well, is the POISSON mechanism, which is just mistake proofing. So, for example, if you need to cut wood for a chair and you only need to cut 5 centimeters, you make your machine stop at 5 centimeters and make it unable to go any deeper. For example, that would be a POISSON mechanism. Yeah, and I think that would be most of our theory recapped as of now. I have uploaded a little Excel file on our website, which has a bit of forecasting methods for your training if you want to do. This is obviously not mandatory, and I've put it in the end of our session so you can still pick. Thank you so much for attending. We will now have a Q&A time. Oh, thank you, Valentin. That's lovely. So if you have any questions, I'm going to be here for a while now. So if you have any quiz questions you're unsure about or anything was too quick, unclear enough,